Good afternoon and welcome. My name is Nigel Blanford from the University of Salford Energy House 2 programme, and this is the last in our sessions on the smart homes ecosystem, brought to you by the University of Salford Energy House 2 and the European Regional Development Fund. Now, they say you should leave the best until last, and in this last session I think we've done exactly that. But before we get into the details, just a few house rules. You're all placed on mute, just because there'll be otherwise there'll be just a cacophony of people chatting away, and there will be questions and answers generally after each session. And if you look up there, you'll see a little sort of text box, a place with a question mark, a little sort of caption there with a question mark, where you can type in your questions for the presenters. So just give you an idea of that, and then we will ask the presenters those questions, or they will pick them up themselves. We've allowed a generous amount of time for questions and answers from the presenters, but if this time isn't fully used up, basically we'll just advance the session forwards, so we'll finish before 3:30. There is very much here a bias towards the energy side on the smart homes, pardon me, but that's because that's where our expertise lies. But you can transfer these skills to not just the energy side, any part of the smart homes ecosystem. Please be patient. This is our first attempt at a webinar series online, and it's particularly interesting because this time we have presenters that will be live streaming in from Portugal in 2 different locations, so this will be very new for us. So these webinars are brought to you by, like I say, the European Regional Development Fund and the University of Salford. We are here to assist Greater Manchester SMEs. Those of you from outside of Greater Manchester have those to thank for these sessions, and having attended these webinars, they'll have the opportunity to potentially be in the position to use our facilities to research and test their products and services at zero cost. If you are a company outside of Greater Manchester, you're welcome to have your products tested by us, but this will be on a commercial basis. So without further ado, what we'll do, final point, there'll be a small comfort break at the midpoint. You will have been emailed the rooms to go into, but at that time, the sort of 15-minute break, we will put up a holding slide and have the URLs written on there as well. Before we go into this session here, you will see on that question thing, so if you go up to the question and answer box, you will see that there has been some published questions here, and these are a URL to a site, a email and username, and a password which you can cut and paste in, so this can be used in this session coming up. So what do we expect from this session? Well, this first session we have is from Critical Software, talking about the smart homes ecosystem and home energy management systems. Jose Figueiredo is a software engineer with a master's in software and computing engineering. He has worked for and ended up heading for many years an engineering department that's developed hardware and software technologies for the smart metering industry. He has in-depth understanding of communication protocols and its full stack implementation. He's also participated actively in the development and launch of broadband IoT technologies such as NB-IoT. More recently, at Critical Software, Jose has led several R&D projects for the UK's smart metering implementation programme, of which Connector X project is part of. Now, it's not just Jose doing that. We also have Doega Farinha, I think I pronounced his name correctly. So he has a master's degree in electrotechnical engineering with a major in control and industrial electronics. During his master's degree, he made research of signal processing applied to EMG signals to integrate on the assistive robotic hand orthosis controlled with EMG. So without further ado, I will hand over to Jose. Thank you. You need to unmute, Jose. That's it. Yeah.
Yeah. Hi guys. Just warn me when the presentation is up. All good? Visible? Okay. Hello everyone. I am José Figueiredo from Critical Software, and I would like to welcome you to the ConnectorX presentation. ConnectorX is a critical software R&D project in partnership with the University of Coimbra. Presently, in many smart homes, we have two distinct sets of smart technologies. One set of smart home technologies is all those systems that are monitored and controlled by the home user, such as temperature and humidity sensors, lighting and energy socket controls, intrusion and emergency sensors, and many others. The other smart home technology is the smart metering system, which is currently monitored and controlled by the utilities and other associated entities. These two systems are currently independent with no commercially available solution that integrates both into one. What are the advantages of integrating them? By supplying the user with real-time and historical data from the smart metering system, the user can then decide in what ways he can act or behave so that his energy or gas usage is more adapted to his real needs. This way minimizing his utility costs and ultimately his carbon footprint. By improving these integrated measurements and controls, we not only save up in our home costs, but also improve our comfort, safety and security in our lifestyle. These four categories and its derived benefits can be achieved by using a combination of the integrated technologies, such as using energy time of use information to manage the schedules of our home appliances. For example, selecting a washing cycle during a low tariff period, or controlling the whole metering system based not only on temperature and humidity sensors, but also on information from the smart metering system. How do we integrate both systems into one? The UK Smart Metering Implementation Programme and the SMAT specification has specified a device designated as CAD, Consumer Access Device, which is an access point to the smart metering system by the home user. Connector X is based on such a device, but it was designed not only to access the smart metering information, but also to fully integrate all smart home systems into one intelligent system. As we can see in the presented system architecture, Connector X integrates the most commonly used communication standards used in a smart home. To connect the smart metering system, we use Zigbee Smart Energy. And to connect to home devices, we have either Bluetooth Low Energy, Zigbee Home Automation, or Wi-Fi. We have also included Home Connect, which is a standard for connecting and controlling home appliances over Wi-Fi. Home Connect is supported by Siemens, Bosch, and a few other manufacturers. All the collected information is sent to AWS's cloud platform for storing, processing, and viewing, either through a web application dashboard, mobile application, or third-party application through an available secure API. After analyzing and comparing different cloud platform providers, we ended up selecting AWS because it offered a comprehensive set of services and features that had the needed requirements to achieve the initially proposed objectives and an exciting roadmap to expand its capabilities, especially in topics like machine learning and AI. All this at a reasonable price. So of the comprehensive set of AWS services, we selected a few. For the back-end entry point, we use AWS Iot Core, which offers a secure and scalable connection based on MQTT and digital certificates. To store the data, we are currently using DynamoDB, which is a NoSQL database with almost limitless scalability and fast queries. There's a new AWS database service which might be more suitable, which is called AWS TimeStream and could be an option for future developments. For data processing, we are using multiple serverless lambdas, and we hide all this behind a secure API by using AWS API Gateway. For AI and machine learning, we use SageMaker and Forecast. For voice commands, we use Alexa Skills. For authentication and secure requests, we use Cognito. And finally, the dashboard web application is supported in an AWS S3 bucket. The API is accessible not only by the web application, but also by our mobile application and authenticated third parties, as mentioned previously. For the user interface, we developed a web application and a mobile application. Being an R&D project with limited time and budget, we opted by including for the time being some features on one of the platforms, but not on both, with the objective of presenting the full system's capabilities. For example, we have included Home Connect and Forecast on the mobile application, but currently not on the web application. Nevertheless, both platforms have three distinct sections. The first section is focused on the smart metering data, where we can view meter information, real-time data, charts with instantaneous readings, and historical data. We can also view the meter's current tariff calendar. The second section is focused on the smart home devices, where we can scan, add, and manage the devices, view instantaneous readings, control different actuators, and schedule multiple automatic tasks. The third and last section is for viewing and controlling home appliances. As previously mentioned, Connector X has fully integrated Home Connect, and all available features are accessible through Connector X's API. Besides using the common API, we can also schedule multiple automatic tasks for these appliances, as we did for smart devices, a feature unique to Connector X. By collecting all this data in an AWS database, we can then apply different AI and machine learning models by using AWS SageMaker and Forecast, so that we can predict future energy usage, identify appliances by their digital signature, detect anomalies, and ultimately feedback information to the Connector X to help its autonomous decision making. Currently, we already have energy usage prediction integrated into Connector X, but we believe that appliance identification through its digital signature unlocks a number of possible applications with valuable interest to the user. As part of the Connector X research and development project, and in partnership with the University of Coimbra, we have also published a scientific article which studies, analyzes, and presents the ideal machine learning model applied to a real set of energy data from the London area. This article is currently being reviewed by IEEE. And finally, I'll leave you with a quick view of Connector X's final electronic hardware. Okay, before moving on to a demonstration, are there any questions in terms of what we presented?
So just to recap, if you have got any questions, if you look up again up there into the top there, you see the caption box with a question mark. You'll need to type any of your questions into there if you want to get them answered. Thank you.
Just wait a few minutes before
moving on to the live demo. No questions? Maybe we can move on to the live demo. Nigel, what do you think?
Yeah, move on. There are no questions.
Okay, probably at the end. Okay, so I'm going to share just a second.
We can see you there, Jose.
Okay,
At
yes,
your desk. Yeah.
just going to share another one. Sorry. Can you all view the desktop? Okay. As Nigel said, he shared in the Q&A a link to the dashboard with the credentials. Whoever wants to access it and view the same information that I'll be presenting you at this moment, it will be on the same device. Except on your access, you won't be able to do certain things, such as in demo mode. But I'll be presenting the application on our side. Okay. So as I mentioned in the presentation, we have several sections, different sections. I'll be presenting first of all the web application with the applicable sections of the web application, and then we'll move on to Diogo, so they can present the mobile application and a few other features for like Alexa, for example. Okay. But for now, inside the web application, in the main screen, we start off by presenting the metering data. Before I go on, I'm not sure if I'm on a camera or not, just to show what we have in view. Just because we have a panel here with the meter, with the sensors, and with the Bluetooth sensor and the Bluetooth light with the device, and we also have a home connect coffee machine from Siemens, which we'll be using in this demo. So the metering data that we are viewing here in terms of the information and the meter real-time data is from this meter on this panel, and it's reading, and this reading, the acquisition readings are being acquired every minute and sent to AWS for your viewing. So what can we see? We can see all the data from the meter that is available through the SMETS2 meter as defined for for UK. Basically, total energies, active power, the pricing, the monthly consumption, weekly consumption, and so on. We also collect the instantaneous values from the meter, and we send them every minute to the cloud, so we can see the instantaneous consumption every minute. With historical data, we can see the historical consumption, for example, for yesterday and the day before, and so on. So it's all kept in AWS Cloud for future viewing. And we also have the meter historical data. The meters stores some of this data, but we store all the data in the AWS Cloud, so we can view many months and years back in terms of information. We have, for example, all the day consumption, the total consumptions in terms of energy and cost. The weekly consumptions, there was a period the meter was off, so that's why there's an empty slot here. And the monthly consumptions in terms of energy and cost. We can also retrieve from the meter the meter's tariff calendar. You can see what's the specific prices and the periods of the day where the prices apply to, and if there are special days, for example, holidays with different pricings and so on. So we can have an understanding of exactly how our meter is set up specifically for the UK in this case. Okay. The next section is for home devices, sensors, actuators, and so on. We have a sensor section here. At this moment, we are viewing the sensor. It's a temperature and humidity sensor. It's also sending every minute the information to the dashboard, to AWS and to the dashboard. It refreshes the information, as I mentioned, every minute. And you can also view the historical data in terms of the daily, so in a similar way that we were doing with the metering. You can view that, for example, the temperature has been going up in the past couple of hours, and the humidity, the changes also. Battery, it also gives us information about how the battery is of the sensor, and this other chart here is it has to do with the light, the Bluetooth light that we switch on and switch off. You can see exactly what periods of the day was it on and what periods of the day it was off. For the actuator, in this case, we are using a light to demonstrate its capabilities. Can be different types of actuators, can be just simple ones, lights, and so on. But for this one, we are using a light. And in this case, we can switch on and off the light, change its temperature, change its intensity. We can actually just show it to you now. I want to switch on the light. Might take sometimes a slight delay. Here we go. I'm not sure if you can see if the camera is visible of the same area, but you can see that on the panel that the light is turned on. For configuring the devices, we have different areas. We can see all the connector X things. We have all the things that are attached to the system, the features and configurations and so on, and we can add new devices, a scan, for example, for a new Bluetooth device if we acquired, add it to the network and create it, and it will be added to the system so we can control it however we want. As mentioned in the presentation, Home Connect, we don't have it implemented in the web application, but we will have it. We will show it to you in the mobile application. This last section, yeah, we have a scheduler where we can view scheduled tasks for the devices, and we can add a new task. For example, we want to control the light. We want to switch it off at a specific date or after a specific date, for example, for today. And every day of the week, for example, or every day, every weekday, for example, and at a specific time. And we can add different times and so on, and store this in the scheduler. This information is sent automatically to the connector X, to the hardware, and the hardware will update its plan, its internal plan, and control the devices, attached devices. Okay. just check something. Yeah, I didn't configure anything. It was a past date, so it doesn't show up because it's refreshed now. I put for 11 o'clock. It's already past 11, so it didn't show up. Yeah, just go back here quickly to add again, and I'll add a future date for today. Okay, today can be for 2 o'clock. Add. Okay, here we go. And it calculates what's the next settings for the day, and it sends it to the connector X, as I mentioned. Okay, from the web application, this is what we currently have. Okay, I'll pass on now to Diogo. He'll show what else can we do in the mobile application. Basically, can do everything that I showed you, but he'll show you viewed by the mobile application and a few other features that we haven't integrated into a web application. Okay, so passing on now to Diogo.
Hello all. So I'm here to show you the interface for ConnectX that we have also for mobile application. So I will share the cell phone. Okay, I hope that you see it right now. So as Jose said before, we have pretty much the same features that we have on web application. So we have the meter information, for example, where we can see the related meter data, the ConnectX ID, for example, serial number of the meter, and our customer ID. We have a calendar also. This calendar, as Jose said before, shows the prices for each moment of the day or of the week, same as the web application. For the real-time meter data, we have the instantaneous demanded power that shows the instantaneous power consumed at every moment. We have the accumulated energy consumed for the day, the week, and the month. And as you can see, we have also the consumption and a target that we aim to not reach, that is generated with the forecast. So is the previewed energy consumption for this day, the forecasted energy for this day. The same for the week and the same for the month. And we have here also the chart with the instantaneous power consumption for the selected period. Okay, we have also the storization that Jose have also showed. I believe that we have a month of daily consumption, weekly consumption. We have several weeks also, and at this time we have the last 3 months because we do not have more consumption before of that, because the meter have been not turned on. Okay, this is the part of the meter values. We have also sensors, actuators, and the Bluetooth devices. The Bluetooth devices are, for example, the sensors and the actuators. that we can use and connect. So we have the office lamp and the office thermometer, for example. So the office thermometer is a device that has 3 sensors. It measures the own battery level, the temperature, and the humidity. So in real time, we know these values, and we have also the history of each sensor. Okay, I believe that it's the same data that we can find on web application. The same for the other, for example, for the humidity. Okay, it's quite different in some moments. Okay, and for the actuators, we have the lamp that José has also shown. We can this lamp allows us to change the intensity of the luminosity and the temperature of the color. Okay, so we can turn on and turn off the lamp. We can also schedule an action to the lamp. In this case, to turn on or turn off, we can turn on, for example. Okay, select the time. And we have also the periodicity. So we can do it for once time. We can do it in a daily basis, a weekly basis, or a custom. Can do it in a custom way. So I will keep it simple, daily time. And we can tell that this is only valid to the day 14 at 13. Okay. And we can create the task. Okay, now I believe that if we see we have already 2 tasks, the one that I've just created and the one that José created before. Only one is shown here. Okay, something happened. Well, it should be there, the task that José also have created. But let's move on. So I can also change the shut down the lamp. Okay, and it has turned off. I don't know if it has been seen. Okay.
I can see that the lamp has been turned off over in Lisbon. Yes. Oh, it's gone on again now.
Exactly, that's it. Okay, so and the last part is the Home Connect integration. So for our tests, we have a coffee machine that is in Lisbon with José. So we can control the coffee machine with our application of ConnectX. So it's our coffee machine. It says that it's ready. It allows us to control it remotely. So it's ready. So this to grant access to any new appliance, we must before give access in the Home Connect website. So we can select our appliance from here, and when we ask to log in, we are redirected to the Home Connect page to give access to this account to that appliance. So this is our coffee machine. I have already done that. Here we have all the fancy coffees and other things that machine can deliver us. We have also temperature control, the strong, how the coffee is, and how much coffee we want in the cup, not for the ristretto. Let's try another one, espresso, for example. Okay, and in this case we can select the fill quantity that we want. As in the other actuators, we can also schedule the program. I will not do it. I think that it does not worth it. But I think that now a coffee is running out on the machine. If we can see it.
Thanks, Joke, for the coffee.
Is that the type of coffee that you like, Jose? Has he bothered to ask you what type of coffee that you want?
No, it's me who chooses the coffee.
He might not like it though.
Possibly.
He wants to wake me up. He asked for a real double coffee. It's a really strong one. So.
I like the cultural variation of this because, you know, obviously if this was being done in the UK, there'd be a tea making machine there, but obviously a coffee making machine.
Yeah, in Portugal, there has to be a coffee making machine everywhere, in every corner. So.
Okay, and it's pretty much it. So the light is on. Let's try to turn it off. And the next interface that we have to show you is the Alexa. So we have a skill for the Alexa. I have an Alexa Echo Dot to show you, hopefully, that it works. What can we do with the Alexa interface? It can tell us, for example, the energy that we have already consumed. We can ask her for any sensor, for example, the temperature of the office thermometer that we have, or we can ask her to light on the lamp, for example. Okay, so let's try to do it. I'll change my microphone. Okay, I have the Alexa. Let's try it. Alexa, open Connecta X.
Welcome to the Connecta X. How can I help you?
Can you tell me how is my energy consumption today?
Welcome to the Connecta X.
Okay.
How can I help you?
Tell me my energy consumption today. Alexa, open Connecta X.
Welcome to the Connecta X. How can I help you?
Tell me my energy consumption today.
You have already consumed 0.176 kilowatt hour today.
Can you tell me the battery level of the office thermometer?
I'm sorry. I'm not able to find the office thermometer device.
Alexa, open Connecta X.
You consume 0.176 kilowatt hour today.
Okay. Okay, thank you. Let's try it again. Alexa, open Connector X.
Welcome to the Connector X. How can I help you?
Can you tell me the temperature of the officer thermometer?
I'm sorry. I'm not able to find the officer thermometer device.
Can you tell me the temperature of the office thermometer? Okay, it's not collaborating. Alexa, open Connector X.
Welcome to the Connector X. How can I help you?
Can you tell me the temperature of the office thermometer?
I'm sorry. I'm not able to find the office thermometer device.
Okay, it's not collaborating. Let's try to turn on the lamp. Alexa, open Connector X.
Welcome to the Connector X. How can I help you?
Turn on the office lamp.
Okay.
Okay, can we see? Okay.
Okay.
Thank you.
Goodbye.
Goodbye. So we can pretty much do all that we can do, or all that we can see in the other interfaces. We can do it also with the Alexa. And that's it.
Alexa sometimes is very picky in terms of the words, sometimes when you complicate things. But
yeah, she has some.
Yeah. Okay, guys. Nigel, at least what we had we have presented questions.
So we do have a couple of questions there. So if you want to have a look at those, Jose, and answer those.
Mm-hmm. Raj is asking. Okay. Just a second. Raj is asking, do all these sensor switches have to be powered with separate batteries? Well, these the sensors and the switches do have to be either Bluetooth or Zigbee, so they do have to be powered in some way. Can be batteries or connected to the. It really depends on what switch you install in the home. Because the only thing we need to connect it to Connect X is either Bluetooth connection or Zigbee connection. Not sure if I answered the question. If there are any other question, Raj. Okay.
Anyone else for any questions? I thought Yanis, did you have any questions at all?
Yes, hi. Jose, I would like to ask if in the future you are planning to use, instead of the Alexa, the equivalent, the Google Home device as well.
Well, currently we developed everything over AWS, so it was a natural thing to use Alexa. We believe everything that we have done in AWS is possible, building over the Google systems and probably using Google Home. So I believe, yes, it could be a possibility, but at this moment we're focused only on one platform. So we chose Alexa because of AWS. Okay.
Thank you very much.
Any more questions out there? Yeah, we've got another one coming from Raj here. Yeah. Yeah, I think this is something about things being self-powered, isn't it? So I know that, for example, I have a thermostat that controls my heating systems, and currently two control wires come in that power it, that has power in there, but they also control it. But I need batteries to run that switch. The new one that I have, I'm going to have to put a separate power supply in there to control it. I think that's what Raj is referring to.
Yeah, I guess like, as I mentioned, to connect any device to the connector X, it has to be one of these communication systems: Bluetooth, Wi-Fi, Zigbee, any of these. So you would need some device compatible for one of these communication protocols or communication platforms to be able to connect it to connector X. We demonstrated here with Bluetooth, so you can do the same thing with Zigbee. Bluetooth is a bit more of a challenge because not every Bluetooth isn't there isn't such a standard in terms of devices out there. So not every device can be attached immediately to the system. There might be some adaptation needed to be able to integrate it into the system. Zigbee home automation is already more of a standard, so possibly any device can be attached with more clarity in terms of what we can do with the device. Bluetooth is more complicated because the lack of standard, let's say, in terms of home devices. But we do need some communications to be able to reach the system. Okay.
Any more questions out there? I will do my usual sort of countdown here on a 3, a 2, and a 1. Okay, we'll assume there are no more questions. So at this stage, I'd like to thank very much Jose and Diogo from Critical Software and for demonstrating the ConnectX system. We've now got the we're now going to put a holding slide on and go straight into the comfort break. We'll have a slightly longer comfort break just to give everyone a bit of time. This is the last one. We want to meet in the meeting rooms. You have direct links there, and also it'll be shown on the holding slides. We will come back at 13:45. So that's over 15 minutes, a little longer than usual, but we will see you back here at 13:45. Thank you very much.
Welcome back from the break. We are now moving on our last presentation, which will be delivered by Felix Ryan, who is the director of YGHT, which is the abbreviation for You Gotta Hack That. And Felix will present to us the cybersecurity aspect of the smart home ecosystem. A few things about Felix. Felix started a part-time MSc in software and system security at the University of Oxford and moved to become a junior penetration tester at a growing security consultancy. There he was given a wide range of opportunities, including gaining soft consultancy skills as an ISO 27001 lead auditor, a PCI QSA, and gained a distinction in his degree. After rising through the ranks to acting team manager, he then became a freelance consultant penetration tester. Today, Felix finds satisfaction working with any organization interested in pushing themselves to do better. In addition to his professional work, Felix is a keen contributor to the information security community. He produces and publishes tools, has presented at conferences, and has co-authored chapters published by the British Computer Society in conjunction with CREST, the industry's governing body. Thank you very much. Felix.
Hello. Wow, I always find those sorts of introductions really, I don't know, it makes me feel nervous because it makes me sound better than I feel like I am most of the time. But anyway, hello everyone, good to speak to you all. And Yanis is right, I've been doing this for a long time. Can I just check, Yanis, can you see my presentation? Is it full screen? Wonderful, thank you very much. In that case, so who am I? I'm Felix. I'm a penetration tester. Authorized hacker is a better name for it. I'm guessing, gents, you mean like that? Is that correct? No, I can't see you though. The misadventures of an IoT hacker. That's the name of the title because that's hopefully going to be the point of what I'm going to show you today. I'm deeply a geek. I've been doing programming and such like that since I was about 7 years old, I've had a lot of fun along the way. The company is going quite well. We're starting to grow and having some fun doing lots of IoT stuff this year. So just as a summary of what we're going to talk about, kind of a why bother about attacking IoT devices, because clearly this is it's a very specific niche and there's plenty of other targets, so why bother? And then a discussion about why it's a bit different dealing with IoT versus normal infrastructure, and then a bit of a rundown into some of the tactics and techniques that you might well come across with physical attacks and with radio frequency based attacks or RF attacks, and then finally Q&A. Why bother? There's loads of reasons, and to be honest with you, the reasons are there's so many different motivations and what have you that we're not going to cover them all. The fact is that the whole concept of having IoT is very different to normal computing in that you actually give people a device and they are given it to take into their own homes. Which means that all sorts of things that don't normally happen do happen, which is great from an innovation perspective and some interesting challenges from your security kind of side of things. But that can mean all sorts of things. So just because there's so many people who just like to tinker, and so they'll play and attack stuff as best they can, and getting free things or turning on features. So there's so many examples of people who have got a router, just a DSL modem or something along those lines, a little bit of kit, and then they've flashed it with a different firmware because that way it can do more stuff, or they've found a guide to adding extra features that are not supposed to be there, and then obviously you've got some other more commercial aspects like copying it, counterfeit goods typically from China, upgrading it, and then the more interesting stuff. So here, and these are kind of things that are very specific to IoT, is using it to attack someone else. we'll talk about that one again in a bit, but there's all sorts of things you can do when you've got thousands, if not hundreds of thousands of little tiny computers spread out across the world. And then hold the user to ransom. The whole concept of ransomware is very much there, and there's some wonderful little cartoons about fridges that say, well, I'm not going to let you eat anything out of the fridge until you pay me 1 Bitcoin, which at today's price would be a very, very expensive meal. And then the actual kind of the bit that most people think of when you talk about hacking IoT and what nefarious things you can do with it. I think I have. What do you call it? The pivot into network and attack from the inside, which essentially means using it not to attack it, but to attack something else. And there's quite a lot of examples of that in the security world as a whole, anyway. So attacking devices is quite different from the sort of traditional IT and web apps and that kind of thing, and that's often because there's fewer layers of abstraction. Layers of abstraction essentially are where you have someone who's done some clever work and they've done it at a very low level, say, and you're working on top of theirs. So it's standing on the shoulders of giants, to probably miscoin a phrase. And what that means is that the complexity and the difficulties that are happening sort of lower down in the computer system, you don't have to deal with as a developer. In normal IT systems and the stuff that we deal with every day as ordinary users, we've got loads of levels of abstraction because Windows is very complex and there's drivers and ultimately all the way down to ones and zeros being electrical signals, and we don't have to worry about any of that. So there's lots of layers of abstraction, but because of the nature of some of these devices and the fact that they do physical things, or just the fact that they're constrained in terms of their processing power or anything along those lines, the layers of abstraction are taken away, because that way you don't have to have such powerful devices. And the side effect of some of that is that a lot of the, I guess, polish and protective mechanisms that are in place on normal computers just don't exist. They tend to be quite compute intensive in some form or another, so they're just removed. And attacking them clearly then requires a very deep level of knowledge for the inner working of computers, and not necessarily to the physics level, what happens if I send an electron here type level, but just slightly above that. There's also a huge number of areas to attack. The high level objectives then for attacking an IoT device or system is that you can attack the cloud. That's the obvious thing. Is most of these IoT services are services rather than just the device. You look at Alexas or Philips Hue lights. They're all designed so that they connect to a cloud service, which then you connect an app to on your smartphone, or you go to a website to control it, and that's fine. But that's the kind of the traditional bit. The attacking the device is far more interesting from my perspective. It's the stuff I study quite a lot of now and do for my customers. But the other bits that people think about sometimes is using one to attack the other. So using an IoT device, say a Philips Hue light, and then being able to do something with that which then has an impact on the wider cloud, whether that just be a way of gaining remote code execution, so attacking and the ultimate goal of access to that cloud, or whether it's just denial of service or something a little less involved and a little less complex. And the other thing that people don't tend to think about is actually taking one device and then attacking other devices using it. So part of my work involves dealing with customers who have IoT projects that they come to me and say, we've got this and we need some help with it. Whether that be a researcher has done some analysis already and that they've got scared or something else. But one of the things that came up a little while ago was a device which was designed for offices and industrial locations, and it was related to looking after people's cars. I can't unfortunately name it because that would be unfair, but their device was it was possible to take the contents of one of the devices and then from that engineer a method to access all of the other of the same devices around the world that these guys have deployed. So that becomes quite scary, because then how do you know it's happening as a manager or operator of a cloud service and IoT platform? So what are the attack surfaces? There are loads. These are just a few of the radio frequency based ones. So Wi-Fi is obvious, and Bluetooth and so on, but there's more interesting ones that are specific to IoT. So things like Zigbee and Z-Wave, LoRaWAN and 6LoWPAN even, they are variations on a theme, and they're all supposed to be for low power devices, short messages on the most part, and they're designed for use by people, by devices with batteries as well as full-fledged computers. A lot of them have other qualities as well, like meshing, so you can have a very large array of devices across a big geographical area, and they'll all be able to talk to each other because they will pass on messages. So some lovely qualities there, but that just introduces complexity, which then inevitably introduces security problems. And then there's non-radio frequency wireless technologies. So infrared ports, microphones, cameras, heat and pressure stuff, all of these other things that you can't physically connect to, but you can have an interface with. You can impact a microphone. There's been some beautiful research recently about smartphones and microphones, and being able to trigger the smart assistant on a smartphone by using a laser and pointing at that microphone to then be able to make it think that it's receiving an audible signal, and therefore be able to attack the phone by doing that. It's wonderful, very esoteric, I guess, bits of kit, but that's the idea. So there's all sorts of things. A lot of that tends to be very high academia based stuff, so the lasers on microphones is not very mainstream at the moment, but it's definitely out there. It's definitely exciting. And the number of things that have cameras then use that information not to show you an image, but to then analyze what's going on around them is staggering. I mean, the obvious one is things like Tesla vehicles, because they have dozens of cameras on them. But the ability to send the camera images that are fake, they're not a real surround, and the car to believe what it can see is actually quite prevalent at the moment, and it's part of the whole automated vehicle thing, and it's starting to get there, but it's not easy.
Can I just shut in there when it was just going to have a little bit of a. Bear with me there.
No worries at all.
Yeah.
Let's go into.
No. If you just go to share it again, Nigel, and go to share window, you should see his PowerPoint.
So.
Where's the mouse gone? So what slide are we on? Are we on that one?
No, quite a few down. Down.
Where are we going?
Is it resume slideshow and then share it, or is that? Yeah, so then that. Yeah. Is that better, everyone?
Yeah, that's correct.
Is that better? Yeah.
Yeah, that's fine now.
Thank you, everyone. As you can imagine, as a hacker, I don't use Windows very much, so using using this is new to me. I don't use it this way around. I tend to break into it. Okay, so yes, there we go. I've got control. Yes, we've covered the non-RF wireless tech. So this one is the next slide, which is Exposed physical aspects. So a lot of IoT devices have USB ports, and they've got SD cards and Ethernet points and all sorts of other things. And there's some quite specific ones. ODB2 ports up there are for cars. And so actually there's quite a lot you can do just by plugging into those and then gaining access to whatever's on show. And that's great, because that gives you so much capability, so much flexibility as well from an attacking point of view. And then we've got the hidden physical aspects. So once you start tearing down a device, in fact I'll show you that later. The PCB test ports, JTAG, serial, and RS232, and all of those other bits and pieces. There's so many different variations on this, which means that you can have so much fun trying to extract information from the devices, but it's just such a huge attack surface. And then, of course, there's the microchips themselves. So, the items noted here are just a few of them, but you can do stuff, and we'll show you some of that shortly around how you can potentially start impacting processors and flash storage chips. And then obviously, if you can listen to the data being transmitted between one chip and another, then you can potentially extract vital information. You can start getting encryption keys, for example, is the classic option. Okay, so on top of all of that, that's all of the IoT specific bit, but on top of that you have the web applications, the smartphone apps, the cloud infrastructure, and all of the other guts that go with that. So clearly there's a lot there to deal with. So physical attackers, they really do happen. So there's the coined phrase, the evil maid or the evil valet attacker, and essentially this is where you have somebody who's trusted and they have physical access to your equipment, and they do something like plug a device in and then have an impact. There'll be some automated fashion which allows it to very quickly have an impact there. The evil valet is kind of a variation on the evil maid, in that it's about cars. You don't necessarily even know the person, but you implicitly trust them and give them your car keys and let them drive off with your vehicle. Mirai is the name of a DDoS attack that happened back in 2016, and at the time it was by far the biggest denial of service attack that the internet had ever seen, at 620 gigabits. Now, keep in mind that most people's internet at home is about 10 megabits, I think is the average at the moment in the UK. So 620 gigabits is huge, and it's since been surpassed by quite a lot, but at the time it was massive, and that was based on I think it was something in the region of 180,000 IoT devices that were exposed to the internet. And each of those devices was used to then send traffic to a target, and it was controlled by an organised crime gang, I think, although that one might have been a nation state. There's certainly examples later on of nation states doing exactly the same thing, and they wanted to do various things, so it's a case of ransom or just simply taking down the researchers. There's one guy who I won't name, but he gets a lot of press. He's quite big in the information security space, and he's been attacked so many times, and the police have turned up falsely at his door so many times because of being a target of these things. But then there's also obviously hobbyists and researchers, people like me. So the options are just as prolific there within the IoT space as they are for traditional IT and tech. So, starting with physical attacks, where on earth do you start? And the answer here is kind of not the in quotes sexy side of hacking. It's an awful lot of background research and reading and looking and thinking that goes into these things. So open source intelligence gathering. Open source is basically anything on the internet. I mean, it kind of applies to everything, but that's what most people think of. And gathering all of that information together is kind of key. And that can be searching for things like FCC IDs because they have to be published, and that tends to include limited shots of the inside of devices, PCBs, that kind of thing. It doesn't always, but actually once you crack open a device, then you can get properly started. I've got a note in there saying, what about an X-ray? And I have come across devices before now which are they're capable of knowing when they have been opened, and they've therefore got like a tamper switch or something else similar in them. And what that means in practice is that they can, if they're clever enough, they can start to erase the firmware that's on there, or do something else to damage the kind of capabilities of an attacker from doing anything further. So I do know of people, and I've not had to do this yet, but I do know of people who first of all start by getting an X-ray. They literally go to their dentist where they've got an arrangement and get an X-ray of the device, and then start going, well, are there any switches that are touching the case? Is there anything else I need to know about before I start opening this up? But once you've got it opened up, you need a good magnifying glass and a notepad, and there's a couple of images just there of like my little monocle, which is 5 times magnification, and then you can see an image that's looking through it. It's not the greatest image, if I'm honest. It looks very different when you're using your eyeball, but the fact is that some of the writing on these chips is utterly tiny, and only by moving it around in the light and using magnification like that can you get to the point where you can actually see what's going on and start to follow the lines between circuitry and identify the chips. In multi-board devices, one of the really important things you need to do first is kind of identify the general purpose of a particular PCB. You tend to find that they'll be layered on top of each other, and each of those layers will be for a particular purpose. I did some work against a device recently, and it had 2 PCBs that were dealing with physical interactions with motors and that kind of thing. And then there was a PCB that dealt with the screen, and then there was another PCB that dealt with like processing and data control, that kind of thing. And then finally, chip manufacturers are the key thing. So once you identify the chips by reading the stuff off them or any other means, then actually finding the data sheets from the chips manufacturers is really important, because then you can see what the pinout is of each of those chips and then be able to do further work against them later on. So the new objective really for once you've opened up the device and identified chips and that kind of thing is getting copies of whatever the operating system is, and what that tends to mean is getting a copy of firmware when you're talking about resource constrained devices, and that IoT. And you can do that lots of different ways. So first of all, open source intelligence. Can you download the firmware from the vendor? You'll be surprised at how many companies simply upload it to the internet and you can download a copy and away you go. And it'll either be encrypted badly or not encrypted at all, and sometimes it's encrypted well, but that's not as common. It tends to be the bigger named products that do that. But also keep in mind that somebody else might have already got there first. They might have already extracted the firmware, and therefore you don't actually have to do quite a lot of the work, or you can follow their guide and that kind of stuff to do whatever they've done and then continue their work if it's needed. So lots of Googling, unfortunately, or any other search engine. Yandex.ru, and a good non-English one is pretty good, because that tends to index sites that the West don't tend to want to know about for whatever reason. Make of that what you are. But in terms of hardware, what can you do? Well, actually, extract via debug port. By debug, I mean JTAG or UART or serial console, that kind of thing. And there's lots of ways of doing that. There's some images here of some pieces, but the one on the far left is the JTagulator, which is a device that is dedicated for just finding out the pinout for JTAG ports, and then we've got multimeters and so on. So using a multimeter, this is on the right hand side is my rough note. So apologies for my handwriting. This is from a job I did a few weeks back, and essentially when I was suspicious that I'd found the JTAG port, what I needed to do was identify what the pinout of that particular thing is, because unlike the commonly accepted interfaces like Ethernet or USB, JTAG and various other ones, they don't have a set standard, so you can put the pins wherever you want. You can actually distribute them across the entire circuit board if you so wish, but to find them, you can do some basics to get yourself started. So measuring resistance is often a really good start, because once you work out which pins are connected to your ground and your voltage, then you can discard them from being data ports, data pins. But it also helps you identify common layouts, because there are quite a few common ones. You don't have to follow them, but they are around if you want to. And then measuring voltage is really interesting, because it helps you identify potential data pins, because they will have data coming out of them if they are output pins, and that will be a fluctuating amount. So it'll differ, depending on what's going on the board at the time. It'll swap between 0 volts and 2 volts, or whatever the case may be. In this one, I've written TDO, which test data out, and I think that one might be the one. That's why I've got a question mark, and it's I've got 1.2 volts, which is not the same as the voltage reference, and it was varying quite a bit. So using the JTagulator is very automated. This particular tool is really refined, and it's designed literally to do one job. It's a hardware device, and you plug it in and press the go button essentially, and it will give you an answer about which ports are which on a JTAG or a suspected JTAG pinout. And it can do a few bits and pieces other than that as well, but that's essentially the point of it. The JTagulator, along with a lot of the methodology with this sort of work, is actually just to be systematic. And so it systematically goes through all the possible options of all the pins that you've connected and goes, is this what I think it is, by doing some interaction with the chip on the other side. And if it comes up with something positive, then it records that and moves on. So then there's a few other bits and pieces, and I'm going to go into these in a bit more depth, but chip sucking, chip off, logic analyzers and integrated circuit programmers are key terms that we'll come to next. So this is a logic analyzer, and it's I'm not quite actually sure how you pronounce this. A lot of people call it the Sale. I've heard it called the Salile and all sorts of other things before now. But essentially, it is a raw, think oscilloscope, but on steroids. It can do analysis, it can show you timings, it can do them at massively high frequency rates for sampling, and you end up with these incredibly detailed analog and digital layouts of what's going on a particular pin at a time, and then you can apply analyzers to identify baud rates and whether it's I2C or whether it's SPI or anything along those lines, and really go from there. This is hard, and it takes a very long time because you're dealing with the raw ones and zeros of a signal, and there's only so much that the Sale can do for you. But it's a really invaluable tool, and often you can get some quick wins because sometimes it's just obvious and it just works. This is an A6 Forte. It's one of the higher end integrated circuit programmers, and it's designed for the ability to send new firmwares to chips, and actually you can also use it for extracting firmware from existing chips if you don't already have the file. So it reads, verifies, and writes, wherever possible. And it's quite a capable bit of kit. And the device on the right-hand side is a SOIC chip clip. SOIC is a type of chip, and then this essentially, if you've got a chip on a PCB and you don't want to take it off just yet, you can put this clip over the top of the chip, and it will then interact directly with that chip. And you can use that with the PCB turned on, with power going through it normally, or you can just turn it off, and then the Forte will power it instead. So quite exciting different things you can do there. Fact is that there's lots of different chip sucking capabilities out there, programmers out there, and the various different ones have different chips that it's aware of, and different ones that it can actually handle. Not all of them have the ones you want to use, so sometimes you're forced to use a particular hardware because you're dealing with a particular chipset. And then it comes to chip off. So chip off is quite quite good fun, but it's actually a physical skill more than anything else. So removing the chips is, literally what we're talking about here. And to do that, you need to typically add solder to a PCB because it'll have been done by a machine and there won't be much there. You need to do that because you need a thermal load, essentially, which means that it doesn't solidify immediately when you take the soldering iron on. And then you need something like a craft knife just to prise it up a little bit, and then you do one side and then the other side, and until eventually it comes off. The challenge with this is eventually it will get too hot. So wherever possible, I try and stick little heat sinks on them and all sorts of things to try and to cool it down, but whilst leaving enough heat on the solder itself to melt it. I have broken so many chips doing this by just getting them too hot. It's quite difficult. Once you've got the chip off and you're happy that it's working, there is quite a few different ways of then analysing it. So you can clearly see on the left-hand side there with the Forte, I've got they're tiny little grabbers. They essentially get hold of the pin and then isolate it and connect it to the Forte, and that's enough to connect it. But you can also use things like that picture in the middle, which is a lovely little device, which is a spring-loaded thing, which you put the chip in and then it kind of clamps down on top of the chip, and then you put that in top of that USB programmer there, and then it connects and away you go, and it does its thing. The picture on the right has got a bit squashed in transit, but that is essentially the same thing but plugged in and turned on doing stuff. You end up with an awful lot of Frankenstein's creations. So this, all of these images are in fact the same thing, just in various different states. So the bulb on the left-hand side is, it's a bulb. It's an LED Wi-Fi bulb. As you can see in the top middle picture, there is the LEDs. That's once I've taken the cap off, and then you take the LED ring off, and you get another PCB underneath it, which is the picture underneath. And then the top right-hand one is a really interesting bit as far as I'm concerned, because you can see there's some silkscreen or like printed on markings, so ground RXTX, which stands for read and write essentially, and then voltage VCC, and those are target ports. They're definitely something I'm interested in. So I start soldering things on there, and as I'm soldering, I realise that actually voltage in the UK for light bulbs is 230 volts. So I've had to also, and please don't do this yourselves because this is clearly stupid, but I've also had to then wire a plug onto the back of the PCB to get it to naturally power it up properly at UK voltage. As I said, health and safety, people would scream at me for this. Please don't do that. I'm not an electrician either. So protection mechanisms. There's loads of things that people can do to protect their PCBs. I always like to try and talk a bit about how to make things better rather than just talk about the bad stuff. But these items here, I probably won't go through all of them, but there's loads of ways of doing it. The one that I would highlight the most is try and encrypt your firmware. If you can do it both from like an upload perspective from your computer to it when you're upgrading it, and as well as in storage actually on the device, then that makes such a big difference because it makes it very difficult for someone like me to then start interrogating it. You have to start gaining access to the chip whilst it's powered on and has decrypted and so on, and that just gets massively complicated. It's still possible, but it's hard. And then there's loads of other kind of obfuscation techniques, missing components, or not putting your silk screen markings on and pouring glue over the top of stuff so it make it hard to access. Anyway, those are all good fun. I guess the question that most of you might well be asking now is, so I've got firmware, what do I do with it next? And that is where it gets really hard. This is the bit that actually takes the most time when you're hacking IoT. And there's lots of tools out there to make things better. Virtualization is a really good example of that. I had the fortune of, just before lockdown, of meeting the author of Armex, and Armex is kind of like a handler to virtualization. And once you've got a firmware, you can give it to Armex, and it then allows you to do loads of interaction with it on a real computer, so you don't have to deal with the little slow device anymore. You can speed everything up, you can gain access to the memory directly, you can do all sorts of things, and that's really, really helpful and makes a big difference. And then fuzzing, code analysis, library analysis, looking through the source code essentially and seeing what's there. And trying to find things. You'd be surprised how often things like hard-coded values come up. And then finally, you can add extras to the firmware, which means you can then put it back on the original IoT device and gain access to it and start executing commands inside the IoT device. That gets quite interesting because then suddenly you've got all sorts of other things going on. So that was all physical attacks. And now we're going to start looking at the radio frequency stuff. And by RF, I don't necessarily mean the mind-bogglingly physics stuff, because that's really hardcore. And yes, there's stuff you can do there and there, but actually each of these interesting protocols are less robust usually than the ones that we've been using for a long time, because they've not been around for that long. You know, they're also designed for resource-constrained devices and that kind of stuff. So layer 2 and above is in that picture. It's the orange one and all the way up to the top. So layer 1 at the bottom, layer 7 at the top, and this is a theoretical model called the Aussie model. And essentially, if you can start doing things with layer 2 and above, then you've got a chance of having some interesting impacts. So the big questions when you're looking at RF is there any cryptography on the communication? If there is, that makes things, you know, somewhat more difficult, but not necessarily impossible. Can I listen to the content? So, you know, it's kind of a side question to the, is there crypto? If I can listen to the contents, then I can directly infer what the meaning is, because I can see exactly what the contents of the message are. And then inferring meaning from transmissions that are encrypted. Just because they're encrypted doesn't mean that there's nothing that you can infer from it. You know, you can definitely tell. Say if someone's got a Zigbee door sensor on their front door, every time that triggers, you know that that door has opened. So long as you can identify that that is that device, you know that that door is in action, and therefore you can tell when someone went to work without necessarily being there, you know, within reasonable probability. And finally, can I inject malicious messages? You know, so can I tell a device in the network to do something? Can I add so many messages that actually it's impossible for the hub or, you know, any coordinating body or the app or the cloud service or whatever to work out which ones are the real messages and which ones aren't, and therefore fill up your phone with millions of alerts saying something's going on when it's really not. So how do you get started with RF attacks? You need to know what you want to speak. So you need to know what your target is. You know, your Zigbee door sensor, it speaks Zigbee, so you need to know how to speak Zigbee. And then it's getting the right radio equipment. There's so many different options here. You know, the fact is that software-defined radios are like a catch-all. You know, they can talk everything along in a frequency range. This particular one, the Hack RF1, is kind of a mid to low range software-defined radio, SDR, and it can talk everything from, I think it's something like 1 megahertz all the way up to 6 gigahertz, which covers a huge amount of potential options there. But to talk anything at all, you have to tell it exactly how to talk. You know, it is literally a raw radio that you can do anything you want to, which makes it very flexible, but takes a lot of time to do anything with. Whereas you can go to something like this, which is a Zigbee array of sniffers. You know, each one of these little green lights, the little circuit board sticking out that USB hub, is a Zigbee sniffer. And there's reasons for sticking in an array. We'll maybe talk about that later. But the fact is that these are very cheap. You know, 12 to 15 pounds on Amazon. You can buy a whole array for every single channel of Zigbee for about 180 quid. And that comes with software that just works. You know, there's tools for the Zigbee devices you've just seen. One called the Killer Bee set. And Killer Bee is a suite of tools that is on GitHub, so publicly available, and is absolutely free. But and it does very specific jobs. Open source tools tend to be a little bit on the ropey side because they're not commercialized. You know, so they do a job, they do it well enough, but they probably need a little bit of expertise to run it, and you need to know what's going on to be able to make it do anything extra, anything a bit different. And to go with most of these tools, what you end up with from like the SDR or from those Zigbee sniffers is a packet dump. A packet dump is literally just a recording of the packets that were observed at the time. Wireshark, excuse me, is a good packet dissector. You can see a picture of it just there. That one in that particular image is looking at TCP packets and HTTP packets, so normal network traffic, and that's not very exciting from my point of view. It's not very IoT, although there's bits of it there too. But those packets in the green section is literally line by line, that's a packet. And then you can see in the bottom half, you can see the raw data, the hexadecimal data, and then the analysis in the middle there of what actually these bits and bytes mean. It's very, very interesting when you start looking at it in depth. Granted, you have to be fairly geeky to find that interesting. And then no one likes this bit, but reading the RFC, these documents are huge, but they are very specific, and they can often end up with an attacker's mindset revealing flaws within the protocol. So this particular RFC is for IPv6 over Bluetooth. So this is literally trying to send data via a computer, for a computer type network over Bluetooth. And this will be, potentially hundreds of pages long. It'll all be in the same font. It'll be referenced, all like that. It's sort of extreme academia in many respects, and they're hard to read. They're very dry, but they will give you a massive amount of detail. It's also worth noting that not everybody implements the protocols exactly like they are in the RFC. So if you know the RFC and the way the protocol is designed, but you're spotting alternative behavior, there's a very real possibility that there's a vulnerability there, because inevitably the RFC is done for a reason. And if it's not being done like that, then you might well be able to find a weakness. There's so many examples of that throughout history, particularly around cryptography. This is a picture of the Atom Homie, and it's a very spherical device. I'm going to try and show you my test one. This is something I've been playing with for a while, and I hope you can see this as well as the screen. This device is it's spherical, and it's a consumer grade bit of kit. And you can see there the lights on the edge of it, they glow, and in fact they glow and they move and they do different things depending on what you've told it to do. The inside Atom Homie is just a normal circuit board. This one is a nice and complex one, and you can see some interesting things straight away. The part in green is Z-Wave, and then you've got a piece towards the top, almost top left, which is the Zigbee antenna, and you've got those two spiral-looking things, which are various frequencies for normal. I say normal RF, non-specific protocol RF. And then when you actually start looking closer, you've got all sorts of things on this particular one. So you've got a Wi-Fi chip, you've got Zigbee, Z-Wave, Bluetooth, infrared, 868 megahertz, and so on, as well as the hidden stuff. So the console access, and then you've got USB. You've actually got a network adapter that is designed to work over the USB channel. So you plug in a USB to Ethernet adapter, and then suddenly you've got this extra capability. There's loads of chips on it, and there's even a tilt sensor in there, which is a bit unusual in IoT. And they all do various things. And the reason for Homie having all of these different things is because it is a smart home hub. So it's designed, its sole purpose in life is coordinating or orchestrating all of the other smart bits of tech you have in your house. So, your fridge and your Sonos and your lighting and all of the other bits and pieces you can possibly think of. It's designed to be able to cope with it all, and bring it all into one app on your phone and have this this one point of concept. And therefore be able to have one thing trigger another, rather than the disconnected and sort of broken IoT ecosystems that we have to have at the moment, which is many different things talking to lots of different things in its own little way. I have been doing research on this for a little while, since about mid to late 2019. I've been doing this in my own time. This is a personal project, and it's got the specific requirement of me being able to publish the work at the end of it, and that's because I don't get to publish any of the stuff that I find on my customers' targets, because that wouldn't be fair. But the Homie has a couple CVEs. I'm the publisher, the author of both of those. CVEs are common vulnerability enumeration, and there is an international database of all CVEs. So CVE, and then the year it was registered or found, and then the sequential number in the year. So this particular one is number 9462 of 2020. This particular one is a minor vulnerability in many respects, but it's quite a common thing that I come across. What this particular device does is when you're enrolling the device, it spins up a Wi-Fi access point, which is unencrypted, and you connect to it with your smartphone. And then it says, what is the name and the password for your normal Wi-Fi network, so that I can connect to it, please. And what it does is it then sends from your phone to the Atom Homey in an HTTP transaction, unencrypted, your Wi-Fi password. So anybody who's nearby can listen to your Wi-Fi traffic to the Atom Homey and then capture that, and then they can then connect to your Wi-Fi network and attack whatever's on the inside of it. So this is clearly not a good thing, but it's not the worst thing in the world, because that's only done whilst it's being set up. There's ways of socially engineering people into doing setup of these things after the fact. You know, that's definitely a thing. But in terms of how bad CVEs and vulnerabilities can get, that's not that high. You know, it scores, depending on your opinion, between 3 and 5 on the CVSS score, which is like a 1 to 10, 10 being awful, 1 being not that bad, really. I have a second vulnerability on this, which has been published actually about 2 days ago, and it's still marked with last year's date because I registered it last year, late in the year, but because of something called responsible disclosure, which we'll talk about in a minute, I didn't publish it until the vendor had a chance to respond and potentially put a fix out there. This one is about Zigbee and the Zigbee implementation within this device. They clearly didn't follow the RFC and the exact specification for Zigbee, because they used, and I kind of assume that they didn't even think about it, but they used a default and well-known static network key. So even though you still go through an enrollment and exchange of keysing, which is a flaw with Zigbee itself, but that's not with Homey, that's the whole protocol flaw. What they did was then just always deliver the exact same key, and it would always, no matter where it is, which device it was, or anything along those lines, you'd always have exactly the same key. And it took me more time than I care to admit, really, to spot this. You can see on the left, you've got the array, you've got the physical array, and then you've got a tool, which is the killer bee running there. And then I've taken a little snapshot from one of the packets in Wireshark. And the bit that's highlighted in blue there is the key that's being exchanged from the hub to the device that is being enrolled, and you can see there it's 01, 03, 05, 07, and so on, and that's in hexadecimal. And when you convert that into decimal, that's 13579, and you start going, hang on a minute, that's a bit of a pattern, and it's got some. It's not quite a perfect pattern, but it's pretty close. And that's so unlikely in that size of key to have naturally occurred that it must be hard coded or human generated in some description. And that's between the Texas Instrument is the Zigbee chip on the Atom Homey, and the Philips happens to be a Philips Hue light bulb. Not Philips' fault because they just received the key. Sorry, so I've reported this to the vendor to talk about responsible disclosure, and they typically have like 90 days is kind of the accepted norm to go away, make a fix, and then to implement a change. And you can negotiate that. There's nothing set in stone. But I've had several emails with my friendly support guy, and he told me within an hour of me emailing in that they had worked out what the problem was and that they were planning a fix. And then I think it was within 10 days they said that they had a fix in preparation. It was in testing phase. It was part of a much larger deployment, and they weren't 100% sure that they would get it deployed in time for the 90-day deadline. I've said, look, it doesn't matter to me if it's a few weeks later, so long as we've got an agreed deadline and it doesn't go too far. And that has been published. This particular Atom Homey has been updated, and I did various tests to prove that actually you always get a new key, and it's a nice strong cryptographic key. They've also made some other improvements as well to the Zigbee stack at the same time, which is definitely a good thing. And they can comfortably say actually anybody who upgrades will hopefully end up with a new key. There was some ambiguity about how you'd do this if you had an existing deployment, but on the most part it looks like it's pretty good, and certainly any new deployments will definitely have a new strong key. So this is a really good result. I have various things I can show you guys if you're interested, in more depth, say if you wanted to look at the JTagular in more depth and that kind of stuff. So please do ask if you want to have a look. And I'll do a bit of a show and tell. I've got a giant antenna here with me. And any questions? Thank you very much for your time. So, Yannis, over to you.
Felix, thank you very much. Really interesting presentation. We have been working with Felix for quite a few years now, and we have utilized the Zigbee sniffer and Wireshark, and it is amazing the information that you are able to access and analyze through this device. Really, I would like to ask our attendees if they would like Felix to clarify any points, or if you have any questions.
Hopefully the silence in the room means that I did a good enough job of explaining myself.
Exactly. Felix, would you like to provide us with, of course, without providing names, etc., as you would never do, of a couple of projects that you have recently been involved with?
Sure. Cool, that's a good question and difficult to do without giving away too much. So I have been working against a medical device actually of late. It is designed to obviously look after people and help people stay healthy, but in particular it's quite a complex device. It's got many different PCBs, and they're all very specific to a particular task, and they have no markings on it whatsoever. It's quite an I guess quite a difficult board to work out, really, because it's so complex and there's so many different options for things like JTAG and so on to be found. But it it was quite interesting to work against, and has some real problems in terms of the compliance requirements. So most IoT, it's consumer grade, so within reason nobody really cares, but with medical devices there's a lot of oversight, and that means regulation, and the standards that they've got to comply with are fantastically complex. So this particular device, I helped an organization get themselves assessed to UL 2900, both part 1 and part 2. And my part in that whole project was doing the technical assessment and sort of the penetration testing of it. That was fantastic. That was really good fun. And I think there's definitely a push towards more of that. There's standards being developed in the EU for generic IoT. So there's an organisation called the Iot Security Foundation, and them in combination, I'm going to get this wrong now, I think it's them in combination with DCMS, which is one of the government departments in the UK, managed to get a standard produced, or a set of guidelines to start off with, and it's now becoming an EN standard for the minimum level of security for IoT devices. So if you're in the position of operating or creating an IoT platform, please do have a look at some of those resources, because they're brilliant. And actually, if you were to get that top 13, I think it is, things done on your IoT platform, you would be in such a strong position compared to the vast majority of stuff that's out there. I don't half go through a lot of PCBs. If I'm given stuff, like that medical device, I was given 5 of the devices in the end, and by the end of it I will have destroyed probably all of them. They tend to be fairly large projects and multi-phase ones. So that particular one, you do a discovery phase for a few days, and then you do like a hardware teardown and trying to access all of those hidden console access, JTAG, all that kind of stuff, which might take a week or 2 weeks, depending on if it's really complicated, and then firmware analysis can be like a month's worth of work. So sometimes it can be really big and complex, but other times it's not that bad, but it's very exciting, very interesting. Does that help, Yanis?
Absolutely, yes. Felix, also, would you like to, because now it is this massive initiative, almost, well, not almost, in all European countries and in the stage of the smart cities, would you like to say to us a few things about the cybersecurity aspect of the smart cities, because smart cities is dozens of devices interconnected somehow, and I'm sure there will be vulnerabilities in various of these devices. And as you have described to me in our conversations, always your system is as secure as the most vulnerable of these devices, isn't it? Would you like to say a few things about that?
Yeah, sure. So the fact that smart cities exist at all is quite astounding to me, because the possibility for it to go horribly wrong is so definitely out there. I think the fact that it hasn't done already is a sign of maybe that there's not that many bad people out there. Just an idea, but also possibly more relevant is that the barrier to entry to these things is actually very high. So you start looking at very simple electronics, and there are not that many people around who understand how the chips are actually put together, let alone how to take advantage of them. And so because of that, I think it's highly likely that we'll get to a point where people are starting to skill up. You find outfits like my little boutique consultancy firm that are trying to specialize more and more in IoT, and that's because it's a growing place, and there's going to definitely be more and more problems in this space. But right now, it's fascinating that it's not been that big a deal. I think one of the areas of most interest to me, I'm involved in an automotive project and cybersecurity and hacking things like CAN bus and all sorts of things. And vehicle to X, or V2X, is fascinating, and that's because V2X is all about the vehicle interacting with stuff in its ambient environment. So, traffic lights, street signs, and road markings, and all of those other bits and pieces, as well as embedded RF generating sensors within the road itself in different circumstances. There's been all sorts of stuff tried, and the whole idea of V2X is probably going to be the most prevalent or first most prevalent smart cities thing that kind of really hits the mainstream, in my opinion. And the reason I think that is because everyone really has access to a car, whether it be an Uber or whether it be your own vehicle. And the major push, certainly by westernized governments to go towards electric vehicles, goes hand in hand with some of those smart vehicle stuff. And you just have to look at things like Tesla's and the way that they're thinking about the future for them to recognize that they need to embed all of these bits of kit. There's already been multiple vehicle hacks, and most of those have been around a particular type of vehicle. There's the famous Jeep hack from a few years ago, where someone managed to sit in a hotel room with a laptop and gain access to a Jeep's computer over the internet, and then get it to I think it slammed its brakes on and swerved to the left on a highway in an interstate in the US, and that's clearly really serious. But the smart cities element to that is taking it one step further, which is how long will it be before someone sticks a street sign which is erroneous on the side of the road, which tells vehicles to stop at a particular junction rather than to continue on a 70-mile-an-hour road. And will the vehicle know that actually, if it gets a stop sign on the road and it's on a motorway and it's doing 70 miles an hour, will it know that it doesn't need to slam its brakes on and prepare for an emergency stop in case there's traffic coming? Or will it be clever enough? And the opposite applies as well. Is if someone's clever enough to have programmed that car to not respond to that sort of thing, that sort of environment, will it be clever enough to know when it is a real circumstance and it does need to slam its brakes on, which is the more important thing, because in either way round you can see the potential for, you know, a risk to life. So that's why I think it will be the most prevalent place for cybersecurity aspects to come into smart cities, because, you know, it will hit us all, hopefully not literally.
Felix, thank you very much for your response. Are there any other questions that you would like me to pass, Felix, before we finish? Cannot see any questions coming, so I would like to thank you all very much for attending the workshop. I hope that you found the workshop useful. It was, as Nigel has said, it is the first time that we ran this workshop online. The previous one was before the lockdown, so there was more interaction, etc. So excuses for any small issues or problems that we might have. We will try soon, as soon as possible, to convert all videos like in on-demand form and share them with you in case you have missed some of them. We would like to ask if you could contact us for feedback, and on behalf of all the Energy House labs, we would like to thank you very, very much for attending this workshop. Bye. Thanks.